Okay, we're back now, ready to look at graphing rational functions again. So I'm going to pick us out a function here to graph. It's going to be f of x equals 2x divided by x minus 1. And let's think a few minutes about what we did earlier. First of all, we did the domain, so let's write that here. X cannot equal 1. Now remember in that one that had the open hold that we reduced, and when we reduced the problem went away, so we have to check and see if we can reduce our function here. We can't because this x is a term, this x is a factor of the numerator, and we can't reduce unless we have common factors in both numerator and denominator. So no, we can't reduce. Well, one thing we've done with our graphing before is to find intercepts. So I'm going to let x be 0, and when I plug in 0 for x, I get 0 divided by -1, which is 0. Now if you kind of panic and think that's the one that's undefined, do it on your calculator. 0 divided by -1, and you'll get 0 instead of a real angry message from your calculator. All right, and now I plugged in 0 for x. Let's plug in 0 for y and see what happens. Multiply both sides by x minus 1 so that we get rid of fractions since we have an equation. And we have 0 equals 2x, x equals 0. We've got the same thing, haven't we? So we don't even need to list that one. Okay, moving on, something else we've looked at before is symmetry. Let's see, what do we do for symmetry? We can check for y-axis symmetry, or we can check for origin symmetry. If we check for y-axis symmetry, we'll let the x in our original equation be replaced by opposite of x and see what happens. So let's do that now. We'll check for y-axis symmetry. So y equals, my new y equals 2 times opposite of x divided by opposite of x minus 1. I get minus 2x equals minus x minus 1. That does not equal my original y f of x, does it? So we have no y-axis symmetry. All right, for origin symmetry, we'll replace our x with opposite of x, and we'll replace our original y with opposite of y. So we end up checking for origin symmetry this way. Opposite of y equals 2 times opposite of x over opposite of x minus 1. So opposite of y equals minus 2x over minus x minus 1. Let's see if our new y equals the old y. To determine that, we need a y, so we're going to multiply both sides by -1. So -1 here gives us a y equals -1 over here is not going to be -1 divided by -1 because that would be 1. Rather, it's -1 over +1. So when I multiply in the numerator, I get 2x. In the denominator, I keep my minus x minus 1. So this is my new y. Let's see if it equals f of x. Looking at my f of x, it's almost the same, but it's a little different. It doesn't equal f of x, so I have no origin symmetry either. Okay, next we're going to look for asymptotes. Well, remember we had an asymptote where we couldn't use a number for x if it didn't go away. So our vertical asymptote is x equals 1. Let's see what we're going to do about a horizontal asymptote. When did a horizontal asymptote occur? That occurred when x went to either positive or negative infinity and y approached some constant. So how are we going to tell if that happens? I think it's a lot easier to tell if that's going to happen if we get our fraction in mixed number form. And I'll show you why here. So we're looking at horizontal asymptotes here. This is our worksheet for that. And I'm going to change f of x to a mixed number. Okay? Now let's see, let's think a minute. When you were in arithmetic and wanted to change 4/3 to a mixed number, didn't you take 4 and divide by 3? Sure, that's what we're going to do. We're going to say our f of x equals, and we're going to divide x, 2x divided by x minus 1. Now we can either use long division or synthetic division since our denominator is linear. I'll do long division this time, and another time we might do the other. So we have no constants, so we'll put in a 0 placeholder. We need a 2 here. So 2 times x minus 1 gives us 2x minus 2. Draw a line, change signs, and add. X does not go into 2, so we're through. Our new y is 2 plus 2 divided by x minus 1. Now let's think. Remember, for a horizontal asymptote, x goes toward infinity. So what happens to x minus 1 as x goes to infinity? If I take 1 away from an extremely large number, I still have an extremely large number. So looking at this fraction right here, as x goes to either plus or minus infinity here, this little thing's going to 0. Remember, if I have 2 cakes and wads of people, I don't get much cake. That's what's happening. So if this is approaching 0 as x goes to infinity, f of x is headed toward 2. Therefore, we have a horizontal asymptote of y equals 2. Okay? Now, we looked at one graph a few minutes ago that I just drew, which is definitely a graph of a rational function, and discovered that it crossed its horizontal asymptote. It will never cross the vertical asymptote because that's a no-no. We cannot use that number, period. So it can't cross that. But could it cross y equals 2? That's a possibility. So the next thing we're going to look at is, does it cross the horizontal asymptote? So let's erase where we found the horizontal asymptote and check to see. Now let's think a minute. If I have a graph of some kind, and I want to know if a line that I draw crosses it, I would set the equation of one function equal to the equation of the line and see if I have a common point. So that's what we're fixing to do. If we have a common point, the y's of the points will be the same. So I'm going to let the y of the asymptote equal the y of our function and see if there's a common x. So I need to clear my fraction. I'll multiply by x minus 1. And I will get 2x minus 2 equals, those divide out, double check it, make sure we're not thinking backwards, 2x. To get just the x term over here, I'm going to add 2 to both sides, and I'm going to get 2x equals 2x plus 2. That didn't do me any good, did it? What about getting all the x's on one side? See if that helps me. To do that, I will need to subtract 2. X from both sides. And that'll get all the x's off of that side and leave me 0 over here. Oh, that's interesting. The x's add out here and here both. And I have left 0 equals 2. Is that ever true? No, that's always false, isn't it? You know what that means? We found a false statement rather than a number for x where both graphs crossed at that x point. So no, we do not cross the horizontal asymptote. So we're going to go to our graph screen next and graph the information we have. And last of all, we may need some additional points, which we will get if we need them. Looking at the graph will tell us whether we need them or not. So going to our graph, and I will refer to my sheet here to get the stuff we need. I don't know why that flipped back on me. Okay. We had found that x could not equal 1, and therefore we had an asymptote at x equals 1. So we'll draw in our asymptote. We had found that y equals 2 gave us a horizontal asymptote, and we had found that we're not crossing the horizontal asymptote, and we never cross the vertical asymptote, so we know we're not going to cross there. Now, points that we have found so far are 0, 0, and we have no symmetry. I think we can tell for this we need some additional points, don't we? So let's decide what we want. We want some points to the right of the asymptote here and to the left of the vertical asymptote so that we get both halves or sides of the graph. So if I have already plotted x 0, 0, I might like to use -1, maybe -2, we'll see, -1 and -2 for x. On the right side of that, I might like to pick a 2 and a 3. And if I'm not happy, I can certainly put in more points. So when I plug -1 into my original equation, I get 1 for the y. When I plug in -2, I get 4/3 for the y, which when I get ready to graph it, I want to think of that as 1 1/3. When I plug in 2, I get 4. When I plug in 3, I get 3. So let's see if we're happy with this. -1, 1, -2, 1 1/3. I think I'm happy with that because I know it's going to curve around here and approach its asymptote. The vertical one and the horizontal one to be exact. And then I graph 2, 4, so come over 2, up 4 from the origin, over 3 and up 3. I think that's enough points to graph this too because I know I'm heading toward the asymptotes. So I have that sketched right there. Okay, see what we might want to graph next. And again, we're going to go through the steps of getting ready. So I think I'm going to back up one and put us in a blank page to get ready. This time we're going to use f of x or y equals 4x divided by x squared minus 9. Now we went through certain steps to get this a few minutes ago. We did domain, does it reduce, intercepts, symmetry, asymptotes, does it cross the horizontal asymptote, and then finally any additional points that we felt we needed once we started graphing. That's what we're going to do now. And what you may not have caught is this. I had a little thing going. This helps me remember to keep it nice and orderly. D is for domain. R is for reduce. I is for intercepts. Symmetry is my S. Asymptotes. Does it cross the horizontal asymptote? We'll pick up one other thing there in a little bit, and then additional points. I call that Drizzica. That's kind of silly, but you know what? It helps keep me on track. So that's what I do to keep on track as we're working here. So we'll start with our function here, and the first thing we'll do is find the domain. Well, it might help us to factor this to see what our domain is here. So f of x equals 4x divided by, that's the difference of squares, so I can factor it into x plus 3 times x minus 3. And at this point I can see for the domain I cannot use 3, I cannot use negative 3. In factored form I can see that I have no common factors, so it does not reduce. All right, if I plug in 0 for x, turns out to be 0 for y. And now if I plug in 0 for y, let's see what happens. Multiply by x squared minus 9 on both sides to get rid of fractions. And I have 0 equals 4x. That means x could be 0. But we already have that one. So our intercepts are the same. 0, 0 is both the x and the y intercept. Check for symmetry then. So let's get a little workspace for symmetry here. Remember that in checking for y-axis symmetry, we let our x be replaced by opposite of x. So we get that our new y, let's just label it new, equals minus 4x, because 4 times opposite of x is minus 4x. And then when I square opposite of x, I get x squared minus 9. That is not our original f of x, is it? So what do we know? There is no y-axis symmetry. Well, let's try for origin symmetry and see. We will let our x change to opposite of x. We will let our y change to opposite of y. So we now have minus y, and that's our new one, equals minus 4x divided by x squared minus 9, because remember right up here we had plugged in opposite of x and this is what it looked like. Now to get just y, we're going to multiply both sides by negative 1. That's our plan. And that leads to our new y is 4x divided by x squared minus 9. That's our original f of x, isn't it? Therefore, we have origin symmetry. So symmetry, we have origin symmetry there. All right, let's look at asymptotes. We said x couldn't be 3 or negative 3, and that didn't reduce away. So we have an asymptote at x equals 3 and at x equals negative 3 for our vertical asymptotes. Now, let's erase this. We'll come back to it in a minute. So we'll have room for our horizontal asymptotes. Now, remember we did that by changing to a mixed number. So we did some division in order to do that. This time we do not have a linear denominator, so we have to use long division. So getting ready here, we'll look at 4x divided by x squared plus 0x minus 9. We'll put in a 0 constant, but x squared will not go into that. It goes 0 times. That is actually a remainder. This is actually could be written as 0 plus x squared minus 9. 4x divided by x squared minus 9. So I'm going to tell you that the horizontal asymptote is y equals 0. And then we're going to look at why this happens. How do I know that when x approaches infinity, this goes to 0? Leaving an approach to 0 here for our asymptote. Well, let's think about 4x divided by x squared minus 9. Incidentally, if you do this with any remainder you have, once you get past your whole number for f of x, this will work. I'm going to divide by the highest power of x squared in every single term. Okay? So when this reduces, I have 4 divided by x. When this reduces, I have a 1, and that won't reduce, so I just have 1 minus 9 over x squared. Now think, if I have 4 cakes and x is approaching infinity, just more and more people are coming through the door, I might as well have no cake. Well, the 1 stays a 1, and the same thing happens. If I have 9 cakes, but the people coming through the door is just getting huge, I might as well have no cake. So that approaches 0. And you can test it. Every time you have a remainder here, it will approach 0 as x approaches infinity. So that means our horizontal asymptote is y equals 0. So quick trick, if lead term into lead term is a constant, which in this case it's 0, we have our horizontal asymptote immediately. Let's see, drizk, cross asymptote. And A is additional points. Okay, let's see if we're crossing the asymptote. Get us some room here. If my line y equals 0 is crossing my f of x, then it means the y's would be equal, or the x's, but it's much easier to say the y of one function, which is 0 for our asymptote, and the y of the other function are equal. So this is the y for our horizontal asymptote. This is the y for our f. So if they cross, we're going to have a point where the two y's are equal and the two x's are equal. So let's find the x where the two y's are equal. Multiplying both sides by x squared minus 9. We get 0 equals, these divide out. Look, I've gotten that before. X is 0. Yes, we got 0 for x, and when I plug in 0 for x, horizontal asymptote says y is always 0. So 0, 0 is where they cross. Also happens to be the intercepts we found up there. So we have a lot of information now, and we are ready to graph our function. So looking at this one, let's go back and look at it. Make sure I've got the right function. 4x divided by x squared minus 9. Okay, ready to go. We had an asymptote at x equals 3, so we'll dot it in. we had an asymptote at x equals -3, so that's my two verticals. And then my horizontal asymptote was y equals 0. And for my intercepts, we had a 0, 0, which was also where the graph crosses the horizontal asymptote. That's the only time it crosses the horizontal asymptote, so I don't worry about a crossing anywhere out here at all. So let's dot back in this. Okay, I believe we need some additional points, don't you? I just don't think that's enough to graph it. This time, though, we have the graph divided into 3 sections. So we need to choose some numbers to the right of the asymptote, to the left of this one, and in the middle between them until we get enough numbers to feel comfortable graphing. So that's what we'll do. For numbers to the right, let's see what we might pick. We might pick a 4 and a 5. And in the middle, we might want maybe a 2 and a -2. And over to the left of the last asymptote, we might want a -4 and a -5. All right, and I want to bring our equation back up here because I want us to look at the equation as I tell you the values. So our equation was y equals 4x divided by x squared minus 9. When I plug in a 4, I get 16/7. Which of course I'm going to graph as 2 and 2/7. Now think a minute. If I plug -4 in here, I'm going to get the same numbers I got for +4 except right here. That's going to make a negative where I had a positive. So with that origin symmetry, we can write -16/7. All right, if I plug in 5, I get a number that reduces to 5/4. That means I get -5/4 for this one because of the origin symmetry. If I plug in 2, I went ahead and changed this to a mixed number. -1 3/4. +2 then will be -2 rather, will be +1 3/4. So I'm going to graph 1, 2, 3, 4, and 16/7, which is 2 and 2/7 right here. And then 5 and 5/4, that's 1 1/4, so 1 1/4. And yes, I think that's enough points because I know I'm headed toward the asymptotes and there are no more crossings out here because the only crossing I found was at the origin. Then I'll graph 2 and -1 3/4, -2 and +1 3/4. And yes, I know I'm going to head toward the asymptotes here. So what I have to do is get ready to do a little wiggle through the origin, and I've got the middle section. And now for the left-hand section, -4 and -2 and 2/7. 1, 2, and 2/7 down. -5 and -1 1/4. Looks like that. And there's my graph. For f of x equals 4x divided by x squared minus 9. Okay, we'll continue with graphing rational functions later.